Hello and welcome back again to Ram Circuit class. Today we have very important and very basic topic that is you have had gone through in class 10th as well, that is Ohm's law. Ohm's law is very fundamental to understand the electricity and the electrodynamics, and we are simply moving inside the regime of the electrodynamics. Okay, so coming back to the point, not even wasting our time. So according to it, if this is a conductor of say length L and this is surface area A and this is connected to a cell of EMF, or it's providing a voltage of V. So what happens? Current starts flowing. That is what? The negative charge particles will move where? To my house, or to Washington, or to IIT Madras. No, they don't simply move any of these directions, rather they move to the positive end. Fine? Or in other words, we say they are simply constituting what? Electric current. So if I is the current, and this is a conductor of length L, then Ohm's law says that at constant temperature and pressure, the current is directly proportional to the potential difference across the ends of the conductor. That is, or in quantitatively, V is directly proportional to the current. If current is more, it means potential applied is more, or if you apply more potential, you get more current. So this is giving V is equals to Ri, where R is a constant of proportionality and R is numerically equal to V over I. That is called resistance of the conductor. Okay, resistance of a conductor, and we shall not going into the deep of this Ohm's law. So this is V, that is I. So the more you increase the V, the larger becomes the current and the graph becomes straight. Okay, or it can be written as, if this is the current, this is the potential, again we get the same graph. Say for sake of now this is 45, so this will always be 45. Okay, means what I mean to say is the VI graph will be a straight line. It means R is constant under constant temperature and pressure. This is simply Ohm's law, right? So Ohm's law gives you a new kind of constant called resistance, that is the ratio of potential difference applied across the ends of the conductor to that of the current passing through the conductor. Okay, now the resistance has got something to play with our mind, that is it depends on some factors. Okay, it depends on some factor, and these factors are as given by Ohm sir, that is resistance of the conductor is directly proportional to the length of the conductor. That is, more the length of the conductor is, larger the value of resistance is, because electrons have to travel a longer distance, so they will be colliding more and more against what? The electrons, other electrons and the ions. So we shall discuss that, what the collision simply plays a role in defining the resistance afterwards. So for sake of now, the length is larger, resistance of the conductor becomes larger, and one more thing, R is proportional to 1 over area, that is larger the area of cross section, lower will be the resistance. So we combine them, R equals to, we get a constant that is known as rho L over A, or rho is equal to R A over L, and this is known as the resistivity of the conductor. Remember, this is an internal property of the conductor. However long, however thick the conductor may be, but the rho does not change if the material does not change. That is, if that of same material, then changing the length or even its dimensions does not change the value of rho. Fine, this is internal property. It can only be changed by changing its temperature or its internal configuration. Like if you change its temperature from 100 degree to 600 degrees Celsius, then rho increases, that is R will increase. So one more thing, if you increase the number of conductors or decrease the number of conductors, then again this rho will change. However, for now we are simply managing to this limit, that is rho is equal to this, and resistance simply depending on L and A. So what will be the unit of resistance? SI, unit of resistance, is equal to VI, V over I. V is what? Volt, and that is ampere, that is volt per ampere, or this is denoted by ohm. The symbol is ohm, omega, and this is denoted by ohm, or this is you know what this means is, what I mean to say is, this is the resistance of that conductor is say 10 ohm, 50 ohm, or volt per ampere. So if by this relation what I get, this is equal to 1 ohm if 1 volt of PD, that is potential difference across any conductor, produces a current of 1 ampere. That is, when 1 volt is applied across the ends of a conductor, and if current is 1 ampere, then we say the resistance of that conductor will be how much? 1 ampere. That's it. Nothing more discussion to be done. Now we are coming to different idea. Suppose this battery is producing a voltage V across the ends of the conductor, and this is positive terminal, this is negative, so this terminal becomes positive and this becomes negative. So there, this potential or this cell will produce what? An electric field well across the conductor, that is throughout the volume of the conductor, and say the direction of that electric field is equal to, say this is E, and this will be directing from positive to negative. If L is the length of the conductor, then we know that potential is the product of the electric field produced and the length of the conductor. Agree? And this comes from where? dV upon dr is equal to E, and we are simply taking what? Magnitude of that equation, not taking into the direction. This is taking direction. I is the current. If I is the current, then, and R is the resistance of the conductor, then again we have, if I is the current and R is the resistance of the conductor, then what? This V is equal to I into R according to Ohm's law. Now R is equal to what? Rho L over A. Agree? This can be written as I over A and rho into L. So now this is potential and this is potential comparing. What we get? E into L is equal to I over A, rho into L, L cancels L. I over A is what? Current density J into rho, correct? Now J is equal to electric field E over rho, 1 over rho multiplied E. Rho is what? Resistivity. And inverse of resistivity is called conductivity of the material, and that is denoted by sigma. So this becomes sigma, that is J is equal to sigma into E. Sigma is a scalar quantity, J is a vector quantity, E is a vector quantity. So vectorially we have what? J vector is equal to sigma into E vector. Okay, and this is known as the vector form of Ohm's law. This is very important relation in electrodynamics, and this has been asked many times in your exams, that is board exams. So please note that. Very simple. Potential equal to electric field produced and the product of the length of the ends. And according to Ohm's law, this IR, comparing these, I over A is what? Current density. And finally we are getting J is equal to sigma into E. Okay. So this is known as the vector form of Ohm's law. Vector form of Ohm's law. Okay. So note this down.